notation, I expect you to be completely and absolutely polite and attentive. And if you don't understand something he's saying, please raise your hand and wait to be called on. If he doesn't know your name, it's okay if he says, "Hey, you."
Oh, I guess I should get some paper for some notes.
Like scientific notations, I'm not sure what they're used or like what you use them for necessarily, but I know like what you're supposed to do with them. So, like we're gonna just try to do scientific notation with one number that like let's say has like a lot of zeros after it, like just to say something like that. So we need to get it the decimal right now is right over here, but we need to get it over right here. So we're gonna move it over to the left like 6 spaces. So we'll have 9.1. And then we're gonna put times 10, because that's how many times you divide by 10 or multiply. So then the exponent will be whatever many spaces you got. So that would be to the 6th power. And you have 9.1 times 10 to the 6th power for getting to it. And you can do that like the opposite way too, like you have 0.0.
Mr. Wise,
Yeah.
we have a question.
First of all, can you just tell me like what scientific notation is?
Not really.
Where'd you get the 10?
Do I?
Where'd you get the 10?
I'm not sure, but what? I know you need it to write it in scientific.
Mr. Wise,
Yes.
if I did it like in my calculator right now, and I did 9 1/10 times 10 to the power of 6, would I get the original number that you have up there?
Yeah.
If I like put that in my calculator, could I do that right now just to see if it works? Do you mind?
It has something to do with like how you move the decimal over, because that's multiplying and dividing by 10, so that's where it would come from. And then the exponent says pretty much how many times you do it, or how many times you move over the decimal.
Wow,
We're fancy.
Okay, so like if that works, what if I was like a scientist and I was learning about what is it called? Half-lives?
Oh my gosh.
Yes.
Half-lives. And something got really tiny. Or it got Okay, so would it be easier for me to write down, like erase the 6 for a second?
We're talking about scientific method.
Come on in.
For a second.
Yes, and we've got a guest teacher today. What if that was times 10 to the 112th power? Would you want to write that number down?
Not really.
Seriously, how could you?
Did you put the line over
How
it?
could
Like,
you?
No, you can't put the line over it.
That's like how we do that repeating decimal.
It's not repeating.
9 and a 1, or
Goes
is that
to
a decimal?
12.
Okay, now, guys, I need you to listen up, okay? And River, you're doing great. I'm just going to interrupt a little bit. When a number gets huge, I mean really huge, it's too big to write down. And scientists actually use scientific notation because they can say that my number is 9.1 times 10 to the 112th power. That's going to be an enormous number, right? That's going to be like a Google, right?
Yeah.
Okay. If we had the opposite, now this is kind of a crazy thought, but if I took a piece of paper and I cut it in half and I dumped half on the floor, I'd still have a piece of paper, wouldn't I? If I cut that in half and I dumped half, I'd still have a piece of paper. Could I keep cutting it in half? Would I ever not have a piece of paper? If I kept cutting it in half, would I always have something?
Yeah.
Would it become microscopic?
Mm-hmm.
And would I need special equipment?
Yeah.
Like a huge microscope? Because
Yeah.
it would get so tiny and I would need a tiny little razor blade to be able to cut it in half. But could I continue to cut it in half for infinity?
Mm-hmm.
I could. I could.
Wowie.
Okay? But do I want to write that number down? No. Scientific notation allows me to write huge numbers quickly. That's what they're for. Or extreme small numbers quickly. So, Mr. Wise, go ahead and tell us that next number.
Well, okay, and to be honest, I didn't really think about that because, like, through the book, you wouldn't see too much written down.
That's because
I
books are
think,
crap.
so
I said that out loud.
for this
Sorry.
one,
Oh, dog.
you're going to want to get like the decimal over in front of the first
Well, at least we
number.
know it's not just us.
Like, that's not a 0. So you move it to the opposite direction 4 spaces. So that would be, you'd have 1.2 times 10, and you'd have a negative exponent, which would be to the negative 4 because you moved 4 spaces.
So if we put 1.2 times 10 caret negative 4, what are we going to get?
0.00012.
So can we try that, please? Did we get that?
Yeah.
Okay. And then I'm just curious, and I'm going to be your co-teacher for a minute, okay? If we took 10 to the negative 4th, how would we write that with a positive exponent?
1 over 10 to the 4th?
1 over 10 to the 4th. So now we've got a fraction of 1 over 10 to the 4th. So 1 divided by 10 times 10 times 10 times 10 is going to be a stinking small number, right? Really, really tiny. And I'm going to take that part of 1.2. I'm going to take 1/1000. Is that right? Is 10 to the, what is 10 to the 4th? Is it 10,000?
Yeah, it's 10,000.
10,000. I'm going to take 1/10,000th of 1.2 and I'm going to set it aside. 1/10,000th. I'm going to take 1.2 of a mineral, or what have you guys learned in science? What's something I could cut?
Cheese.
Okay, so I've got 1 2/10 piece of cheese. So I have a piece of cheese and I've got 2/10, and here it is, and I'm going to cut it into 10,000 equal parts. And I'm going to take one of those tiny little pieces, and that's going to be my snack.
Oh my god.
Yeah, that's ridiculous, right?
Gee.
But does that give you any idea how tiny? Teeny, 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 tiny. So instead of
That's
writing
healthy.
these teeny, teeny, tiny numbers, Mr. Hill, we write them in scientific notation. When you see a negative exponent, your brain should immediately think super small.
Yeah.
Okay? Super small. Everybody say it. Super small.
Super small.
And when you see a giant exponent, positive, is that number what?
Huge.
It's giant. Right?
Huge.
Okay. So this is just a way to write a problem faster. Mr. Wise,
Yes.
I noticed that you have a 9 and then a decimal. And then I noticed that you have a 1 and then a decimal. Can it ever be 2 numbers in front of the decimal?
I don't think so. I'm pretty sure it has to be like a single digit with decimals after.
Does it always have to be a single digit?
I think so, yes.
Yeah.
What are the possible digits that could be the first number in a scientific notation? What are the possible digits that could be before, so on the left side of the decimal, what are the possible digits that it could be? What do you think, River?
Wait, could you repeat the question?
River.
Yes, like,
Boston. What are the possible digits that could be on the left side of the decimal in scientific notation?
1.
1? Okay. There could be 1 digit?
Yeah.
So what digits could they be? Specifically, what numbers could go in front of the decimal?
1 through 9.
Brilliant. Right? Could a 10 go there?
No.
Could a 0 go there?
No. Wait.
Yeah.
C.
Yes.
No.
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 1 through 9. That's it. You have to have a 1 through 9. Or it's not scientific notation. Okay?
Yes.
All right, River, keep going.
Okay, so the only other thing I had was how to divide and multiply by these.
Sweet. Okay,
Coolio.
if you're not watching, now's the time to watch.
And I'm for like I think if for multiplying I got one example, but like for dividing I had to use the books because I kept working out the math and there were two big numbers, so. So I think this one's dividing. Yeah. Okay.
Oh, you're doing a division first?
Yeah.
Okay,
Start with the hardest.
that's fair. What if I want to try this on my own before you do this? Can I try it? You guys want to try it?
Sure.
Okay, give it a try.
I remember doing this
Okay,
last year.
Try this problem. And books really aren't crap, guys, but books don't give you that full in-depth, I'm just saying, they don't give you that full in-depth understanding of real life. They just don't. They can't. They don't, they don't talk. They don't communicate.
Oh, did I say that out loud?
Yeah.
It's my favorite
I'm
thing.
just trying
Sometimes.
to recover.
Oh,
Yeah, I am.
dog. It's a big number.
Trying to cover up your
Sometimes I have a little Tourette's. It just pops out. I can't help myself.
I think you might need to cut down on the coffee.
You think that's
Never.
cosmic?
Yeah.
It could be. All right.
Wait, no, I'm not ready.
Wait for it.
Okay, yeah.
Dr. Brown, this is our new teacher today, River Wise.
Hello.
River Wise, have you met Dr. Brown?
Probably not, but
You should go over and extend your right hand out and shake your hand. That's the right thing to do when you meet someone.
I'm glad to meet you.
glad to meet you as well.
River is explaining to us how to divide scientific notation. All right,
Alright.
River's going to go ahead and finish explaining.
So what I do here that the book says, kind of what I assume the book says anyways, is you take the top exponent, subtract the bottom exponent to get the third exponent, which would make 10 to the negative second power, and then you just take this and bring this fraction down, so you have 7.22 over 3.78 times 10 to the negative second power.
Okay.
So then if you go through with like a calculator and stuff, you'd have it be somewhere similar to 0.019.
Yep. Are the numbers on the right side by where the exponents are they always going to be the same? Like 10?
Times 10, yeah. It should always be times 10 to some kind of exponent, depending on like how much it does, because it's like how the decimal moves over is by multiplying or dividing by 10.
Okay.
You guys, we're the only country that I know of in the world that doesn't use metric. Metric is based on tens. And the cool thing about tens is when you multiply by 10, you're moving your decimal to the right and the left, right? You divide by 10, you move it to the left. If you multiply, you move it to the right. So tens or powers of tens are really cool. They're real easy, they're fast, and scientists have figured that out a long time ago. That's why they use scientific notation.
Can you just put the original problem in your
Are we
calculator?
based on
Yeah, that's what I did.
Yeah,
And I got the
that's what I
same
did
tool.
too. I think you probably could. I'm not.
Unless I take your calculators away from you.
Yeah, they just do it that way.
All right, do me a favor though. Would you guys do me a favor and divide 7 2/10 divided by 3 7800ths? And write that number down times 10 to the negative second power and see what you get. Would you tell River what you get, please?
Yeah, you get that.
What, 1.9?
Approximately.
Yeah.
So could we write 1 9/10 times 10 to the negative second power?
Yeah.
Would that be an accurate answer?
Yeah. Like,
And it would stay in scientific notation?
Yeah.
Why would it not be accurate, Macy?
Because that's the approximate number that's not the exact number.
What is the exact number?
1.9047619.
It's irrational, there is no
Yeah.
exact.
Oh, it's irrational. So
See.
we're gonna have to cut it off at some point. Could we go ahead and put some more digits out there if we wanted to?
It's a
We
waste of
could.
time.
That wouldn't be
Well,
fun though.
To get it more precise, wouldn't it be nice to have maybe 3 digits past the decimal to give a thousandths, just so you've got a better, solid picture?
But,
Because
yeah.
again, if this is 1 9/10 miles, and I'm doing railroad tracks, and you decide not to be precise, and we're in a train going 120 miles an hour, and you just left out 20 feet of the track, what's going to happen to the train?
You're just like gone.
You're just like gone.
Precision
You're just
might
like
be
gone.
important depending on the value, right? We don't know the 1 9/10, whether we're talking about miles, whether we're talking about inches, whether we're talking about millimeters or we don't know what we're talking about. So is precision important?
Yep.
So, think about it always. If it's big and it's a train track and you're in the train, do you hope the guy that actually decided what the train track was going to be, do you hope he was more precise than Slater?
Yes.
Yes.
Slater likes to cut these numbers off.
Because Slater
And
is
this
not
does not work
funny.
for me. I don't want to be in your train. Okay?
We're not gonna drive the train.
Okay, here's another example. What if it was
Good.
money? What if it was money and somebody owed you money? How precise would you
Slater.
like them to be?
Exactly.
No big deal. No big deal.
Slater.
Exactly.
Okay, guys, do me a favor. He said it's no big deal if you don't give me 9 cents.
$1.
Put 9 cents in your calculator. 10,000 people owe you 9 cents that they didn't pay you. How much money did you lose because you didn't care whether it was precise?
9 cents.
I don't know about you, but 900 is a lot to me. How many of you would like $900 right now?
What?
Oh yeah,
How many of
let's
you,
go.
If everybody owed you $1.09 and they just gave you $1 and said it's close, no big deal.
I'm sorry, that is
What's the big whoop? Right?
Punch them in the throat.
Okay. So in math, it teaches you to be precise, not just in math class, but in real life. You need to be precise on a lot of things that's going to matter. If the speed limit's 55 miles an hour and you're going 59, it's close.
You're gonna get pulled
That officer
over.
doesn't care how close it is. And that ticket's going to cost you about $120. So how precise do you need to be?
Very.
Precise.
Precise.
Not
If
Slater.
you have enough money to give people, then I'm pretty sure that you'll be okay without your $900.
Slater.
You win that much out and you have enough money
No,
to
but what
give
if you charge
Oh,
interest?
dang it. Slater.
Natalie.
Slater.
You're not helping at all.
Okay.
enough money.
I'm really sorry, guys, but I have to tell you this. I own some rental property, and I went to pick up my rent the other day for this guy, and he was $80 short. Now, his rent's only $300, so that's a huge percentage of his rent, isn't it?
Yeah.
He told me, and I quote, "It's no big deal. You can cover it."
What?
What?
Doesn't work that
So
way.
when you live in a place, you have to pay your bills. And Slater, it doesn't matter how much money somebody has. They've worked hard for their money.
Yeah.
And if you owe it, you owe it. And you never have the right to assume somebody doesn't need it. Never. Done.
Then it's
Stop.
one of those
No, we are
Stop.
done. We are done. All right. So back to scientific notation. I'm going to tell you. No. All right. Scientific
Oh,
notation.
God.
Do you guys see any relationship to scientific notation, relationship to what we've been doing the last 3 days with dividing and multiplying exponents?
Yeah.
Do you need to know how to divide and multiply exponents before you can do scientific notation?
See.
But since you know how, does this look pretty easy?
Yeah.
Okay? Will you put one more problem on the board, please?
All right. And this one's like multiplication, or do you want division? Or
I don't care. You do whatever you want.
I have a multiplication. This is multiplying exponents.
You nervous, River?
What?
Is that a 9 or a 4?
That's a 4.
That's a 4. Okay. That's a 4. We haven't got into variables yet.
Yet.
Oh.
That's 4 times 10 to the 5th power
Oh, I thought that was S.
times, that's 5th, times 3 times 10 to the 10th power.
And then, like, I'm not sure, I saw they were all written over 1 in the book, so that would just be equal to the thing on top.
Yeah, you basically just take a 1.
Why do you guys
Yeah.
think that we would write it over 1? What could possibly help us in that case? Brilliant. Negative exponents. That whole
Fantastic.
thing would come down, wouldn't it?
Yeah.
Not just the 10 to the negative. That whole piece, 3 times 10 to the negative, that is a family. It's a group. You don't split it up. You move it all to the denominator.
1 is an important number.
What?
1 is an important number.
What do you-
think?
1 is important?
Yeah, I feel like it's very
Well,
important.
it's lonely too.
Well, like,
1 is a lonely number.
well, I know what I'm
It's
trying
the
to say.
loneliest number that you'll ever know.
Ah!
Why?
It's a Beatles song. So.
Yeah.
Okay, go.
So, then you would, like, I usually just rewrite these in parentheses over down here, 'cause that's 3, by the way. And then, like, you would, hold on a minute. So you take these and stuff, so you would get, you simplify all this down except for the exponents where you would add those together. And you get 12 times 10 to the 15th power. And then, since that's a 12 and there's 10 in the 12, you still have to multiply that by 10, or, yeah, you have to divide that by 10, sorry. And you get, to make it 1.2, you have times 10, and you just add 1 to the exponent, which you get to the 16th power.
Wait, why do you do that?
Yeah.
What?
Because 12 is over 10, so you have to have all the 10s on this side pretty
Why
much.
is 12 over 10? What'd you get 10?
It's error.
It's always good.
Yeah.
It's always
Okay,
good.
so because the 12 is bigger than 9, because Boston brilliantly told us that the number to the left of the decimal can only be 1 through 9. So is 12 1 through 9? So you can't have 12. So River's saying because you can't have 12 times 10 to a
You move
power,
the decimal.
you have to divide it by 10 to get that decimal in the right place. And when you did that, you have to say, well, to get it back to its normal number, you're going to have to bring one more 10 out there. So that's where that one more 10 came from.
Alright.
This
so
is not something you will get immediately.
Is there ever a time when you have to add like another? I'm kind of confused why you added 1 to that exponent.
Because you took away 10, and it's like.
yeah, you like divided by 10 here.
Oh, so you.
Oh, so you're adding. Okay. You're adding another 10.
So you're actually multiplying another 10 later to get it back in its true form.
Mm-hmm.
Okay? Because there's 2 forms. There's scientific notation and then there's decimal form, which is either a whole number with a decimal or a whole number with 0.0. That would be decimal form. Or you would have a decimal, maybe 3 or 4 zeros and then a number. That's decimal form. This is scientific notation. Much faster, much easier to work with, but there's constantly making sure that you only have 1 through 9 as your left of your decimal. Do you have a question, Josh? Do you have a question? Okay.
And that's pretty much all I had for this, so.
Okay. So in science class, when Ms. Larrington's talking about half-life, do you think that people writing half-life information would write it in scientific notation?
Mm.
Sure. Anything that's teeny, teeny, tiny is going to be written in scientific notation or super duper large scientific notation because it's fast to write the numbers that way. Right?
Mm-hmm.
That's exactly what you need. How much time do we have left in this class?
Like 1 minute.
Oh, dog.
No, I
Oh, dog.